In this video, I'll explain the simplest way to solve linear inequalities. And we'll also briefly touch on interval notation, and I'll show the inequalities on a number line. And we are not going to use complicated diagrams which are overwhelming and difficult to interpret. So in our first example, we have x bigger or equal to 4. So imagine I have a number line that starts from 0 and it only moves in a positive direction. We want to find a value of x which is bigger or equal to 4. So first we need to find where 4 is on the number line. And we can see that 4 is to the right side of 0. But this specific value which we are interested in is bigger than 4. So if I start at 4, I want to move even more towards the right hand side to bigger and bigger values. So that includes 4 because we have equal to 4, but also values that are to the right of 4 like 4.1, 5, 6, 7.5, or any value that you can think of that is bigger than 4. So that is the bigger side in our inequality. And we can also express this inequality in interval notation. And interval notation consists of two types of brackets. The first are curved brackets, which shows excluded values, and the second are square brackets, which shows included values. Now what we mean by excluded and included is the following. If I said x is bigger than 4, that means that x is to the right of 4, but we do not consider 4 as an option. It means it must be bigger than 4. Then our minimum value would be 4, but 4 is excluded, so we show that by a curved bracket. And this can go all the way to infinity. And infinity is also excluded because x can never be equal to infinity. And we use included brackets when we have, for example, x is bigger and equal to 4. Now, the equal sign is shown in brackets by using square brackets. That means that x can also be exactly equal to 4. So this linear inequality in interval notation would be square brackets with 4 as our minimum value all the way up until infinity, but infinity is excluded with a curved bracket because x can never reach infinity. In our second example, we want to find the values of x where x minus 5 is bigger than 0. But before we continue with that inequality, let's quickly go back to x minus 5 equal to 0. So if I ask you to find or solve the value of x, you would move the 5 to the right hand side of the equal sign and make it positive 5. So you would transpose the 5. So x would be equal to 5. And that same principle applies in inequalities. If I want to isolate x on the left hand side, I can simply move the 5 to the right hand side of the inequality. And if I move the negative 5, it will become a positive 5 on the right hand side. So x would be bigger than 5. Let us again consider a number line that starts from 0 and moving towards the right. Then we know that the value of x would be bigger than 5. So on the number line, we identify the position of 5 and we indicate 5 with an open O. Notice that x is not equal to 5, it's simply bigger than 5. So it's all the values to the right hand side of 5, but not including 5. So it could be 5.1, 5.5, 6, 7, or any other value bigger than 5 up until infinity. And how I show that with interval notation is my minimum value is 5 and my maximum value is infinity. And now I'll use a curved bracket to show that 5 is not included. And I'll go all the way to the maximum value of infinity, which is also not included because x can never be equal to infinity. So that is how we solve for x in this inequality. We first transpose the 5, and we can indicate that with an open O on the number line and all of the values towards the right. And in interval notation, we would use a curved bracket in our minimum and maximum values. In our next example, we have 3x minus 6 smaller than 0. And we want to solve for x in this inequality. Now the same principles apply as before. We can solve for x by moving the 6 to the right hand side, and that will become plus 6. And if I want to find the value of x, I would divide both sides by 3. So if I divide both sides by 3, I have x on the left smaller than 2. Now we consider a number line starting from 0 with positive values on the right hand side of 0 all the way to infinity, and negative values to the left hand side of 0 all the way to negative infinity. And we want to find where x is smaller than 2. So first we locate 2 on the number line. So I indicate that with an arrow pointing towards the left. And this can also include 1.5, -0.5, -1.4, and every real value that you can think of towards the left of 2. Notice that 2 is indicated with an open O, meaning we do not include 2. So x can be any value smaller than 2, but it can not be equal to 2. And now my interval notation changes slightly. My minimum value would be negative infinity, and my maximum value would be 2. But 2 is also shown with a curved bracket because it's not included. In our next example, we have negative 2x plus 8 bigger or equal to 0. And we are going to solve for x the same way as we did before. So I want to isolate x on the left hand side. So I move the 8 over the inequality, and that becomes negative 8 on the right hand side. Now I want to find x alone, and I'll divide both sides by negative 2. So on the left, if I divide by negative 2, I will have x, and on the right I will have positive 4. But notice that the direction of the inequality changes when we divide by a negative. But actually what is happening is we have negative 2x bigger or equal to negative 8. And if I move the negative 2 to the right hand side, I will have 0 is bigger or equal to negative 8 plus 2x. And if I move the 8 back, I have 8 is bigger or equal to 2x. And now if I divide both sides by 2, I have 4 is bigger than x. So it's important to know that an inequality can be read from any direction. So in my notes on the right, if I read from 4, I can see that 4 would be bigger or equal to x. But if I read from the position of x, I can see that x would be smaller or equal to 4. And that is what happens when we divide by a negative value in order to solve for x. So remember that the direction of the inequality would change. So again, I have a number line that are both positive and negative, and I locate 4 on the number line, and I indicate 4 with a closed O because x can also be equal to 4. And we consider x to be any value that is smaller or equal to 4, all the way to negative infinity. So that includes 4, 3.5, 0, or any value towards the left side of 4. And my interval notation, I have negative infinity as my minimum value, and my maximum value would be 4. But now I use a square bracket to show that x can be smaller than 4, but also equal to 4. In my next example, I have a half x minus 4 is smaller than 6. So again, I want to solve for x, so I move the 4 to the right hand side, and that becomes plus 4. And if I simplify, I have a half x is smaller than 10. And now, to remove the fraction, I multiply the left and the right side with the reciprocal of the fraction. So 2 times a half is equal to 1. So on the right hand side I have x. And 10 times 2 over 1 is equal to 20. So x would be smaller than 20. So if I consider a number line, I would find 20 on the number line and indicate that with an open O, because x is not equal to 20, but we start from 20. And we want to find values that are smaller than 20. So that is towards the left hand side of 20. That includes 15, 1 or 2, 0, and every negative value, fraction or decimal which is smaller than 20. And for our interval notation, we have negative infinity as our minimum value with a curved bracket, and 20 as our maximum value, also with a curved bracket, showing that x cannot be equal to 20. In our next linear inequality, we want to solve for x. And what I'll do first is move all the x's to the left-hand side and the constant values towards the right-hand side. So if I move 4x to the left-hand side, it will become negative 4x. And if I move 6 to the right-hand side, it will become negative 6. And if I simplify, I have negative 7x on the left is bigger or equal to 21. And now again, I will divide both sides by negative 7. So if I simplify, on the left, I have x, and on the right, I have negative 3. But remember that when we divide by a negative, the direction of the inequality would change. So for this inequality, x would be smaller or equal to negative 3. So let us consider a number line. And on the number line, we locate negative 3. And because x can be equal to negative 3, we showed it with a closed O. But x now is smaller than negative 3. So that includes values to the left of negative 3, like negative 4, negative 5, or any fraction or decimal which you can think of that is smaller than negative 3, all the way up to negative infinity. And in our interval notation, we have negative infinity as our minimum value, and our maximum value is negative 3 with a square bracket to show that x can be either smaller or equal to negative 3. In our second last example, we have a double inequality where x plus 1 is bigger than negative 1 and x plus 1 is smaller or equal to 5. And notice that I'm reading the inequality from the position of the variable. So x plus 1 is bigger than negative 1 and x plus 1 is smaller or equal to 5. So the way that I recommend to solve this inequality is to ignore one of the sides. So let us just focus on the left side. So if I want to isolate x, I would move the plus 1 to the left hand side, and that will become x is bigger than negative 1 minus 1, which is the same as saying x is bigger than negative 2. And now I can bring back the right hand side where x plus 1 was smaller than 5, and I repeat that calculation. So I move the plus 1 now to the right hand side, and that becomes 5 minus 1. That means that x would be smaller or equal to 4. So when I simplify this original expression, I find that x must be bigger than negative 2 and x must be smaller or equal to 4. So let us consider a number line, and we find negative 2 on the number line, and we indicate negative 2 with an open O, and we also find 4 on the number line, and we indicate that with a closed O, because x can be smaller or equal to 4. And what we learned from this inequality, that x can be any value between -2 but not equal to -2 all the way up to 4, including 4. So in our interval notation, our minimum value would be -2 with a curved bracket, and our maximum value would be 4 with a square bracket. And in our last example, we have -3x plus 5 is bigger or equal to -19, and -3x plus 5 is smaller than 8. So first, let us solve for x in this inequality. So I want to isolate x, so I move the 5 to the left-hand side, and that becomes -5. And if I simplify that, I have -24 is smaller or equal to -3x. And then I divide both sides by -3. So x would be smaller or equal to 8, because -24 divided by -3 is equal to 8. And remember, if I divide by a -3, the direction of the inequality changes. And now let's repeat those calculations on the right-hand side. So again, I move the 5 to the right, and now it becomes 8 minus 5, and that is equal to 3. And then I divide both sides by -3, so x would be bigger than 1. So remember that you read the inequality from the position of x. So x would be bigger than 1, but x would also be smaller than or equal to 8. So let us indicate those values on the number line. So I have 1 with an open O and 8 with a closed O, because x can be equal to 8, and x is somewhere in between those values. And if I indicate that in our interval notation, I have a curved bracket for my minimum value of 1 and a square bracket for my maximum value of 8.